composite functions. So I've been given these two graphs, an f and a g. Determine the f times the g at 0. So if x is 0, the f function is a -1. The g function at 0 is a 2. So what is the f times the g? So that would be -2. Determine the value of g of f of 4. So I'm going to do this first. So f of 4, so if I go to a 4, 1, 2, 3, 4, that's a -1. So now what is g of -1? So I go to a -1, and then that is a height of 3. Determine a value for k where the f of k equals 1. So now I'm looking for a height of 1. So I could be here or here. So where am I? So you could say 2 would have been an answer, or you could say -3. Okay, given these points, find the f of 3. So the f of 3, doing that first, so that is 4. So now what's the f of 4? So at 4, the result is 2. Number 3, given these two graphs, determine the g of f of 0. So f of 0 equals 1. So that's where I am. Now I got to do the g of 1. So the g of 1 equals 2. Number 4, I've been giving these two equations. Write the equation for the f of g of x. Okay, so I'm going to plug this into the f function. So this is going to go into that spot. So that is my equation. Now, if I think about graphing this, it's a radical, and the x-intercept, or the shift, let's see where this equals 0, so I'm going to move the 2 over. So if I think about that, I'm going to be at 2/3. That's kind of the idea there. So my domain is from 2/3 to infinity. So why is there a restriction? We cannot square root a negative number. Okay, so I guess we could have talked about that has to be that way. So therefore, that's our same solution to this. It's two ways to think about it. Okay, so given that, write the equation of f of g of x. So we're going to input the g into that. So now y equals x squared minus 1. And it says to sketch the graph. So this is a parabola shifted down 1. 1, 1, 2, 4. that's the graph. Okay, we have been given the f and the g. Sketch f of g of x. So we're inputting the g into the f. Okay, so y equals, I can use that because that is labeled y, is the square root of that squared minus 1. So now squaring that cancels, and I get just x, which is going to just be a line like that. But let's talk about the domain. The domain on this one is restricted. So here, x, so -1 makes that 0, and then we have to stay positive on that one yet. So I'm going to take this and I'm going to cut it off right at -1. Given the following two functions, evaluate. So g of f of 3, so I'm going to do f of 3 first. So if I plug that in, I get the square root of 3 minus 1, which is the square root of 2. And I'm going to leave it. So now what's the g of the root of 2? So the root of 2 squared plus 1. So that would cancel and just give me 2 plus 1. So then my final answer would be 3. Okay, I've been given those two functions. Write the equation of f of g of x. So I'm going to input that into the f function. So every time I see an x, I'm going to replace it with an x plus 1. So that's my new input. Okay, so that's going to get FOILed. So x squared plus 2x plus 1. And then this is going to get distributed. And then when I collect, I have no x's now. And 1 minus 2 minus 3 is -4. Sketch this graph. So it is a parabola with a shift down 4. And then the x squared is just a slope of 1, so 1, 1, 2, 4, 3, 9, etc. There's no restrictions on my domain because that's good to go and that's good to go. Number 9, given these two functions, evaluate. So first we're going to do g of -5. So 3 times -5 minus 6, and then we absolute it. So -21 absoluted is 21. And now I'm going to do f of 21. So plugging in a 21 into that makes the square root of 25, which comes out to be 5. Is it possible to evaluate with the other way around? So if I did the f of -5 first, and then this would not be possible. Cannot square root a negative, or this function has a domain. The domain is you have to be bigger or equal to -4. given the f and the g function, determine the equation of f of g of x. So I'm going to put that into that. Okay, so that's fine to leave it like that. Its domain, so remembering here, this is a restriction, the non-permissible value of x equals 5. So in its domain, I could write negative infinity to 5, and then again from 5 to infinity, or x can be any real number except for 5. Determine the x-intercept. So the x-intercept is where y is 0. And the y-intercept is where x is 0. Okay, so now I'm going to solve for both of those. Okay, so negative 2. Now I'm going to times both sides by x minus 5. Now negative 2x plus 10 equals 1. So x equals negative 9 over negative 2, or 9 over 2. And this y equals negative 1/5 plus 2. So I'm going to make this a 10 over 5. So y equals 5 over 5, which, hold on, why did I change this to a 5? There we go. 9 over 5. And that's it. Okay, number 11, we've been given two functions. Taz was asked to find the f of g of x, so should be plugging that into those positions. So what was the error? Right there. Didn't replace the input position. So you have to replace every x with this as the new input. Okay, given those two, determine g of x. So we're going to input this into itself. Okay, so the input squared plus 1 is the function, and now the input is that. So the input squared plus 1, and now I'm replacing the input. Okay, so that's fine if you leave it like that. If you did want to simplify it, we're going to square this. So we get an x fourth plus 2x squared plus 1 plus another 1. And so that would be simplified. Okay, number 13. We were given these two functions, determine the equation f of g of x. So we're going to take this and put it into that position. Okay, so this ends up being simplified on the bottom, x plus 3. Sketching this graph, so negative 3 is a vertical asymptote, And then when you do the rules of degrees, higher on the bottom makes your horizontal asymptote 0. Okay, and then I'm just going to do a few points. So -2, -1, and then I'll do a -4, -5. So 1 over 1 makes 1, 1 over 2. So I should have -2 comma 1, -1 comma half, and there's my shape. And then on this side, -4 plugged into the bottom makes 1 over -1. And -5 plugged in makes the bottom -2. So -1/2. Given this function, justify why f of f of 2 is undefined. So f of 2 equals 2 over 2 minus 1. 1 minus 1 equals 0. And f of 0 makes 2 over 0 minus 1. Undefined, since we can't divide by 0. 15, given those, determine the g of f of x. So I'm going to put the f function into the g function. Okay, so that was the replacement there. So when I square this, it would cancel. So the function is x minus 1, but we need to talk about the domain here. So x has to be bigger or equal to 2 on that function. So we also have to include that on our composite. Explain why the domain is restricted. Because the domain of f of x is that, since we cannot square root negative numbers. Okay, given those two functions, determine g of f of x. So I'm going to put that into that. So I get the square root of x plus 1. And that's the equation. It says to graph this now. So that's a radical. So -1 is the shift of the starting point, and then I'm going to go 1, 1, 1, 2, 3, 4, 2. Number 17, I'm given these points to evaluate f of 0. So f of 0 equals 2. Now f of 2 equals 4. And that's my final answer. Given the graphs of the f and the g, determine the f of g of 2. So the g of 2 equals 0. And then the f of 0, this is where I'm looking, is 4. So my final answer is 4. Number 19, identify f of 2. So f of 2 would equal 6, and now f of 6 equals 5. given the graphs of f and g, determine g of f of 2. So first f of 2, so 1, 2, right here, the height is 1, 2, 3, 4. The g of 4, so 1, 2, 3, 4, now I'm looking there, and the height is -2. Given the two functions, determine f of g of x and its domain. So I'm going to put this into that. And so this already has a domain, has to be greater or equal to 0. Okay, so f of g of x means to put that in place of the x. And then this would cancel, which would be a line if I graphed it, but I still have to remember to stop that line has a domain of greater or equal to 0. Given the two functions, identify f of g of x. So I'm going to put the g into that place. So -2, replace with the input. So -2x minus 14. Okay, so that would match B. Okay, given the f function, sketch the graph of f of x. Okay, so h of x equals, I'm going to put that back into itself. So negative input plus 2. So that's how I'm saying I'm replacing the x, and I'm replacing the x with the function. Okay, so this makes positive x minus 2 plus 2, which now makes just x, which is just a straight line, and there's no restrictions on my variable. Explain why this does not have any restrictions. So because f of x has no restrictions, the composite function doesn't as well.